Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting to you a simple presentation on basic statistical analysis. Okay, so be advised that most of the sources that I put into this presentation are from the internet. So if there is any what you call impact of copyright. So the copyright of those materials belongs to their owners. Okay. The introduction. Okay. The word statistics has several meanings. Okay. Data or numbers, the process of analyzing the data, and the description of the field of study. So it is unavoidable that when we deal about statistics, we are dealing with numbers and data and ways of analyzing the data to come out with a meaningful, what you call that, summary of it. Okay. So it is derived from the Latin word status, meaning manner of standing or position. Okay, so it is being first used by tax assessors. Okay, so that's typical. Okay, so the next word, which is important in statistics, variable, or sometimes they call it as factors. Okay, so these variables are any characteristics or quality that varies. Okay, so that's the word variable comes from. Example, to collect a basic clinical and demographic information on patient with particular illness. So may include sex, age, height of the patient. So each one of them are one variable. Okay. So in statistics, we can divide statistics into two main types. They are descriptive and inferential. Okay, so when we talk about descriptive, it's more on describing a certain nature of observation. Okay, so which include activities such as collecting, organizing, summarizing, and presenting the data. Whereas the second part is inferential, which is to infer or to make predictions of a certain trends of observation. So in inferential, some of the things that may be conducted, making inferences, hypothesis testing, determining the relationships between the variables, and also extending those relationships to create or to make predictions. Okay, so today we will be going in exclusively on descriptive statistics. Okay. So it is a term given to the analysis of data that helps to describe, show, or summarize data in a meaningful way such that patterns might emerge from the data, because we as a human being are very keen on identifying patterns. So if we are dumped with a lot of numbers, we might not be able to fully grasp the observation. But if we are able to process them and to create such patterns from those numbers, then it will be easier for us to identify the meaning that the number is trying to describe. So in descriptive statistics, it does not allow us to make conclusions beyond the data that we have analyzed or reach conclusions regarding any hypothesis that we might have made. So in descriptive statistic, we only are able to describe the numbers that we have acquired. So there are no such thing as predicting or um, making conclusions of any hypothesis. Okay, so this is the simplest way of describing a data. Even though this is a way of describing the data, it's too simplistic, especially for us pursuing our postgrad or PhD. I mean, I can still remember that my supervisor just asked me to put my descriptive analysis in the appendix. Okay, so for us in the postgrad, descriptive statistic is good just to observe the general condition of the data, but obviously we need to do more than that in order to reach more meaningful observation from the data that we have collected. Okay, next, in terms of explaining to you, is the inferential statistics. So it is concerned with making predictions or inferences about a population from observations and analysis of a sample. Okay, so from here we can make predictions of a current trend. If it keeps going on in the future, okay, what will the trend be like? So things like that. So we can take the results of an analysis using a sample and then can generalize it to the larger population that the sample represents. When we do sampling, okay, we take a small portion of a population and then we did the analysis and then try to generalize it to the population. Okay. Next, three types of analysis. Okay. Um, Here we have three types. We have the univariate, bivariate, and multivariate analysis. Okay, so in univariate analysis, okay, um, it involves the examination of the distribution of cases on only one variable at a time. So we are basically describing one variable. For example, weight of college students. So we make an observation where we weigh all the college students there. We weigh them and then we record their weights. So that is the we are observing one variable, which is the weight of college students. Next is the bivariate analysis. So bivariate analysis involves the examination of two variables simultaneously. Okay, so we are observing two variables, and usually they involves some kind of what you call relationship analysis between these two variables. For example, we observe the gender of college students. So we have a college, we observe the gender of students in that college. And then the second observation, we observe the weight of each of the college students. So over here, we have observed two variables, the gender and the weight. And then it's not too difficult to do analysis to relate between the gender and the weight of the college student. So we have a little bit of a relationship analysis between those two variables. The next level is multivariate analysis. So this is the examination of more than two variables simultaneously. Okay, so we have more than two. So what is one more that we can add? Maybe in terms of race or ethnicity. So we observe the weight, we observe the gender, and then we observe the race or ethnic. So from there, we can do a whole lot more comparison between those three variables compared to what we can do with bivariate analysis. So if we have more than two, even more than three, obviously we can do a lot more relationship analysis between those variables. So the purpose of it is for univariate analysis. Their purpose is mainly to describe. Okay, so we just describe the condition of one variable. So there are no relationship there. Where bivariate analysis, we not only can describe the variables, we can also do an empirical relationship, okay, between those two variables. So multivariate, obviously, we can do a lot more empirical relationship among those multiple variables. So in choosing the right statistical technique, so you have to ask yourself the questions, right? So specific research question, so you may have a research question or hypothesis, and then determine the number of variables in that particular question or hypothesis. So does it have one, two, or more than two? So if it's just one variable, then we are on two. We can do bivariate. If we have more than two, then we can do multivariate analysis. So in univariate analysis, so there are further processes that we have to follow. We have to determine the level of measurement of the variable, and then choose the relevant univariate method of analysis. Okay, so we choose relevant descriptive or inferential statistics. So in univariate analysis, we are describing a single variable, okay, such as the weight or just gender or just race or, okay, those kind of things. And then describe the characteristic of a sample to a few understandable numbers. So even though we are only observing a single variable, but it may involve a lot of observations. Okay, like we are observing the weight of college student. The weight of 100 college students. So that is a lot of observation on a single variable. So our mind cannot grasp all those 100 numbers. So we must summarize those numbers in a way that will make it easier for us to understand. So that is when we need to analyze those numbers with the univariate analysis. So the results from that analysis will give us a basic picture of what the sample generally looks like. Okay, so here I have a very good video clip, okay, by on the channel Chrisflipp on univariate analysis. So you can, go to YouTube and type in this Chrisflipp univariate analysis, and then you can have a look at that video clip. Next. Okay. So over there has been the video has explained about discrete and continuous variable. So in discrete variable, the variables are separate. Okay, for example, male and female. So those two are very different type of variable. So there are two types of discrete variable. We have nominal and ordinal. Okay, nominal variable and ordinal discrete variable. Continuous variable is a variable that can take on infinite number of values, such as have been mentioned there, your age. So if whether you're 5 years old, 6 year old, 7 year old, so those are continuous variable and they are related with each other. Two types here. We have interval and ratio variables. So this is the decision tree that has been presented. Okay, so you have in univariate analysis, you have to identify what type of variable that you are observing, because the type of variable will determine the type of univariate analysis that you can conduct. Okay. So we have the discrete. Okay. So if you are using discrete and nominal data, you can only use mode analysis. Okay. Because it's nominal, it's just a name. So you can only observe the mode of the data. If you are using ordinal data, meaning it has a name, but it also has an order, then you can do another extra analysis, which is median. Okay. Next is continuous variable. If you have an interval variable, you can do mode, median, and mean. And ratio, you can also do all those three. I've prepared a video to explain to you all this type of what they call it level of measurement. Okay. So we have this measurement scale or the level of measurement. We have nominal, ordinal, interval, and ratio. The highest level of measurement is the ratio. The lowest level is the nominal or categorical. So the lowest level we can only use mode, whereas the higher level, interval, or ratio, we can use mean, median, and mode analysis. Okay, so we go to the first one, the nominal scale or level of measurement. This is the simplest level of measurement where when the data value fits into categories. We categorize the data. So the observation are dichotomous or binary, in that the outcome can only one of two variable, yes or no. You can only choose one, yes or no, male or female. So this is nominal. Or if you want to go further, mungkin maybe you can like state where did you come from or where were you born. You can only choose one state. You cannot choose 2 or 3 states. Okay, so you can only choose one. So it is mutually exclusive. Okay, for example, sex of patient, male or female, or even nationality. So what is your nationality? You can only take one. Okay, so next is the ordinal scale. So this ordinal scale, it has an inherent order. Okay. So if we go back to nominal scale, it does not have any order, like yes or no. So which one comes first? Yes comes first or no comes first? Is it male comes first or female comes first? Is it Perak comes first before Selangor or what? So there's no order in nominal scale. Whereas in ordinal scale, we have an additional characteristic that is, which is order. The observations are said to be measured on an ordinal scale. Okay, so clinicians use the ordinal scale to determine the patient amount of risk or the appropriate type of therapy. Okay, for example, rank order of class. Okay, a socioeconomic class, rank order of class, class 1, class 2, class 3. Okay, or visual analog scale. So when you go to the hospital, they have this scale 1 to 10. So you have to tell them in that scale which level of pain you are currently in. So you have the order 1, no pain, 10, a lot of pain. So you can choose whichever number. The level of pain increases as the number increases. So there is an order to that scale. Next is the interval scale. We are already moving into continuous variable. So the interval scale, the data classified by ranking. Okay. Quantitative is a quantitative type of classification. 0 point of scale is arbitrary. Okay. The differences can be quite meaningful. And for example, we have the temperature scale. Okay. Whereas the 0, I believe that is extremely cold. Okay. Time also 0 time means it's 12 o'clock. Okay, so the 0 has a value. Okay, and then the ratio scale, the fourth type is the ratio scale. The data classified as the ratio of two numbers. So again, it's quantitative. 0 point data is absolute, meaning that the 0 point scale can be added, subtracted, multiply, and divide. Again, for example, temperature scale or even weight, height, and those things. Okay. So to give you a better understanding on this type of variable, I have prepared a video here. Okay, it's a good video that you can find it on YouTube. You just type in types of data, nominal, ordinal, interval, ratio from StatisticsHelp. Okay. Okay, so in that video, it has highlighted that the types of data that you collect will determine what type of analysis that you can do. So before you start, doing your surveys or observation, you have to determine the types of data that you will get and what is the type of analysis that you are going to be using. Okay, so again, in univariate analysis for descriptive statistic, these are the type of analysis that we can do. Okay, mean, median, mode. This is for measures of central tendency, and range, variance, and standard deviation measures of dispersion. We'll go into detail about this. Central tendency, simply saying that how much of the data is close to the mean value of the observation. Measures of dispersion would describe to you how far the observations are from the mean. Okay. Inferential statistics. Okay, these are more advanced analysis. We have the z-test, the t-test, and the chi-square test. I'm afraid for the introduction level of this lecture, I will not be covering this part. This part will be covered in other sessions. Okay. Okay, so measurement of central tendency. So we are trying to estimate the center of distribution of values. So a single number to make sense of all the sample, all of our observations. So this includes mean, median, and mode. So these are very simple. Mean, which is the average number. Median, the middle value of the rank ordered number. And then mode, the most frequent value of that rank ordered number. So mean is arithmetically, we can say it is an average. The most frequently used in statistics, okay? So it is an average of the observations. Okay. Median is the middle point of the observation, where half the observation, okay, half of the median is smaller, whereas half of the median is larger numbers. Okay, so use in place of mean when the data is skewed. So when we have a data which is not normal, or it has a lot of outliers or extreme values. Okay, for example, median price of housing. So we know in terms of housing, especially in Malaysia, we have houses which are like hundreds of thousands, but we also have houses which would cost millions. Okay, but the houses which cost millions, most likely there are not a lot of it, so they can be considered as outliers, whereas the majority is at the hundreds of thousands. So when you can even see in reports when they are trying to describe the general price of housing, they would say it as the median price of housing, not the mean, okay, price of housing. Okay, so next is the mode. Okay, it's the value that occurs most frequently in an observation, used for a large number of observations when the researcher wants to designate the value that occurs most often. So the researcher wants to find what type of numbers that comes out the most from that observation. So we have a bimodal or a single model, okay, unimodal or bimodal. If it's bimodal, it has two modes. Unimodal has one mode, okay. Frequency table of the mode is estimated by the model class. Okay, so this is an example, good example actually. Okay, so this is an example of mean median mode related to incomes. Okay, so we know in terms of incomes, okay, some people might have thousands of income. Okay, income is in thousand, or tens of thousands, or hundreds of thousands, or even greater than that, millions, things like that. Income are not many, so they can be considered as outliers. Okay, so this is an example. Let's say this group earns 2,000 a month. This is 3,000, 3,007, 5,000, up to 10,000, 50,000, and 45,000 a month. Okay, so we can look here that there is a lot of people earning like 2,000 a month. So this is the mode, the most frequent. So the mode is the people who earns 2,000 a month. That's the mode. The median is one in the middle. Okay, we have 12 in this observation. We have 12 above and 12 below. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this guy is the 13th observation. So on top of him, there's also 12, 1, 2, 3, 4, 7, 8, 10, 12. So he is right in the middle. He is the 13th observation of the 25 observation. So he is median. So the median is people who earn 3,000 a month. Okay. Whereas the average, the arithmetical average, is the people who earns 5,700. So this is when you calculate the mean, you will get into this group, right? And this is the outliers. There's just one person earns 45,000 a month and even 15,000. These are the outliers. Okay, so I have a video here. Mean, median, and mode calculating, understanding and calculating measures of central tendency. So you can key this in YouTube and take a look at the video. Okay, so let's see. Okay. There is the explanation on mean, median, and mode. So this is the representation of mean, median, mode with bell curve. So if you have a normal bell curve, so the mean, median, and the mode are resting at the same place. So it's the same figure. The figure of the mean, the median, and the mode is the same. But when you have skewed observations, such as this positively skewed, like the example we had with the salary, okay? So we have a small population that earns a lot of money, which are here. We have a lot of the population earn low. Okay, they are over here. So the median is here. They are lower than the mode. Okay, so this is a positively skewed bell curve. Okay, so how you can remember this positively skewed? The tail here is at the right hand side. So this is the positive direction, meaning that the number is increasing. Okay. Whereas the negatively skewed, you can see that the tail is at the left-hand side where the number is reducing. So this is a negative direction. So in this negatively skewed, the value of mean is lower than the median, and the value of the median is lower than the mode. Whereas the opposite, for the positively skewed, okay, the median is higher than the mode, and the mean value is higher than the median value. Okay, I have another video here. Okay, it is named normal distribution, standard deviation, modality, skewness, and kurtosis. Understanding this concept, it is very important if you plan to use this bell curve in your univariate analysis. So you can key in this in YouTube and have a look at the videos. Okay, so let's move on. Okay, so this have been explained in the video, the shape of the distribution, normal, positively skewed, negatively skewed, and a double peak. Okay, so averages, advantages, and disadvantages. So if we use mean, okay, the advantage is that it uses all data values and it is algebraically defined. The disadvantage of mean that it is easily distorted by outliers, which will produce skewness. So it is also very sensitive towards outliers, extreme value, and skewness. Median is not distorted by outliers, so that's a good thing, and not distorted by skewness. And the disadvantage, it ignores most of the information and not algebraically defined, meaning that it is not arithmetically defined. The mode advantage, easily determined for categorical data, again not algebraically defined, and a geometric mean appropriate for skewed data, only appropriate if log transformation produce a symmetrical distribution. This requires a lot more calculation than the normal mean. Okay, next measurement that we can use in univariate is the range. Okay, it's a difference between the minimum and maximum value in a data set. Okay, so larger range usually, not always, indicates a large spread or the deviation of the values of the data set, meaning that the values that you have observed most likely will be far away from the average mean. Okay, or you might be observing some outliers or extreme values. Okay, so in this observation, set of observation, we have the range of 55. Okay, so range defines the normal limits of biological characteristics. So this is also how range is being used. Variance, next is variance, a measure of how data points differ from the mean. So measure of dispersion for a given score. The larger the variance, the more deviate on average away from the mean. So if we have a larger number of variance, it means that the observations would deviate further from the mean. Okay, so this is the formula. Difficult to interpret because it is in the units of square of variables. Okay, so it's a squared value. Okay. So from there we have the standard deviation. So if we bring this squared over here, then it becomes standard deviation. Okay, so a measure of variation that gives spread of the data about the mean. So it is the square root of variance. So higher standard deviation indicates higher spread against quite same with the variance. So this is a formula for sample standard deviation. This is for population standard deviation. Measured in the same unit as the data, making it easy to interpret. So it doesn't have the squared value here. Okay, so this is the normal distribution curve with the standard deviation. Okay, so between +1 and -1 standard deviation is explaining about 68% of the of all of the observation. +2 and -2 standard deviation 95%, and +3 and -3 standard deviation, you are explaining about 99.7% of all the observations. Okay, so these are the list of statistics that we have covered today. The list of analysis that we can use in univariate analysis. Again, I've prepared a video. I will not go through this one by one. I have a video that will explain it better. Univariate analysis, the numerical variables. Okay, so that video has more or less explained about the use of each statistical method. Okay, I hope you can select which one would suit you the most if you are doing any univariate analysis. However, the univariate analysis is just the beginning of analysis for your data set. You would need to have more analysis because just describing your data set is not enough. We have to withdraw any type of association, or even better, any type of predictions that we can do with our data set would be excellent for level of analysis required for postgraduate studies, especially in PhD. Okay, so with that, I end this presentation. Thank you very much for patiently going through this presentation. And with that, I would end with Assalamualaikum warahmatullahi wabarakatuh.